Today we need to talk about isomers of the functional groups. Just like with isomers of hydrocarbons, you're going to have the same number of atoms of each of the different elements, but you're going to have a little different structural formula. I'm going to show you the easiest way to come up with the different isomers, and I'm also going to try to show you an easy way to remember it by using Table R. So the first molecule we're going to talk about is propanol. So let's draw that first. It ends in Al, just like aldehyde. Starts with Al, so we know we have an aldehyde. When we look in Table R, you can see that means that we have a terminal carbon with a double bonded oxygen. So we have a 3-carbon chain. They're all single bonded, and then a double bonded O on a terminal carbon. So that's propanol. When we make an isomer, we have to move our functional group in order for it to have a different structural formula. If I moved that double bonded oxygen from this carbon and put it here, I would still have propanol. I'd just be looking at it from behind. So I'm not going to put it on an end carbon or a terminal carbon. I'm going to move this to an internal carbon. And that means that I will end up with a ketone. So it will have a different name and a different structural formula. So it's going to look like this. I still have 6 hydrogens, 3 carbons, and an oxygen. Can't change the type of bond between the carbon and the oxygen, or I'll end up losing hydrogens. So isomers of aldehydes are ketones. And when you look on Table R, you're going to see that aldehydes and ketones are right near each other. So ketones are isomers of aldehydes, aldehydes are isomers of ketones. So let's name this. Ketones, if you look at the example, do have a number, and they end in ONE. So this being a ketone, we're going to say 2. It's on the second carbon. Propanol, just like we learned how to name previously. And I'm just going to make a little arrow here. We can also go in the other direction. A ketones isomer is an aldehyde. All right, let's look at our next one. We have ethanol, ending in OL, just like alcohol ends in OL. So we have a 2-carbon alcohol, like so. Sometimes with alcohols, all you need to do is move where that OH group is. In this case, if I move this OH group to this carbon, it would still be the same thing. It'd still just be ethanol. So I'm going to show you that we can actually make ether, and you'll end up with the same numbers of carbons and hydrogens. So here we have 2 carbons. Here we have 2 carbons. Here we have 1 oxygen. Here we have 1 oxygen. Here we have 1, 2, 3, 4, 5, 6 hydrogens, and same here. 1, 2, 3, 4, 5, 6. An isomer of an alcohol can be an ether. And of course we can go in the other direction as well and take an ether and make an alcohol. All right, so let's name that. We could name this methyl-methyl ether or dimethyl ether. Whatever is easier is usually what I pick. Next, we have a halide. With halides, let's draw it first. We have ethane, and there are 2 chlorines on the first carbon, like so. Halides are different than the other ones. You're not going to make a different functional group. All we're going to do is move them. So for halides, all you're going to do is move them, so you end up with a different name. Rather than having both the chlorines on the same carbon, I'm just going to move it to the second carbon. And now my name, instead of being 1,1-dichloro, is going to be 1,2-dichloro. And again, I didn't lose any carbons or hydrogens or anything. So we're going to make a halide from a halide. just moving it so that it has a different name. All right, here we have an ether, which means we have an oxygen bonding two branches. One is a 2-carbon from the ether, one is a 1-carbon. So sometimes with an ether, just like sometimes with an alcohol, you can just move it. In this case, if I moved my 1-carbon over here, it'd still be methyl ethyl ether. So I'm going to have to make an alcohol, which I did not point out before, but I'm going to point out now. Alcohol and ether are right next to each other on table R. So halides you can make halides out of, just move the halogen. Alcohol and ethers you can make into each other, and aldehydes and ketones you can make into each other. So the alcohol I'm going to make, and you actually have a couple of choices. I'm going to put my alcohol on that carbon, but you could put it on the second one as well. So this is 1-propanol. Essentially, if you can name it something different, it is an isomer. And then, of course, we can go from alcohol to ether as well. All right, next we have ethanoic acid. That means we have a 2-carbon organic acid. Stick on that functional group like so. If you recall, when we talked about esters, which if you'll notice, these two are right next to each other as well. Esters are called trapped acids sometimes. So we're actually going to make an ester from an organic acid. So I'm going to take my carbon, but I'm going to link it to the other carbon with the oxygen I got from here. And then I'm going to put my double bonded oxygen off of one of them, and then make sure I have all my hydrogens on there. So over here I have 1, 2, 3, 4 hydrogens, and over here I have 1, 2, 3, 4. Then my oxygens, 2 carbons, 2 carbons. When you have an organic acid, you can make an ester, and if you have an ester, you can make an organic acid. Now, naming this is the tricky part. We name the side without the O's like a branch. So this is methyl. And then the side with the O's, we add the O8, methanoate, like so. All right, here we're going to try using our semi-structural, or sometimes we call this the condensed structural formulas. We have CH3, which means it looks like that, bonded to a CH, bonded to a CH, or I'm sorry, CH2, bonded to a CH3. And then we name it butane. Do another one together. We have a C with 3 H's, C with 2, an N with an H, bonded to a C with 3. This is an amine, so you name the shorter one like it's a branch, so it would be methyl, and then the rest gets amine, ethanamine, like so. We're going to do a couple more together, and then I'm going to have you pause it. We have C with 2 H's, to a C with 1, to a C with 3. What you're going to notice is 2 of our carbons don't have enough bonds. I can't add any H's, because if I added H's I would be changing that formula, and I can't do that. The only way I can satisfy carbon's desire for 4 bonds is by putting in an extra bond between the carbons. Now they all have the bonds they need, and I would call this propene. You could put the number 1 propene. Let's do another. We have C, 3 bonds, C with 2, C with 2, C, and then you see the O and the N together. That means we have an amide, so that's going to be like that, and then that's going to be like that. And when we name these, we count up our carbons and add amide. Okay, go ahead and give the rest a try. So go ahead and check those two. This one was a little tricky. That COO actually works out to be an ester. And when we name that, we name the side without the O's like a branch, and then add O8 to the other. Okay, try the others. All right, here's the rest of them solved. Just some things to keep in mind. This one shouldn't have been too much of a problem for you, nor should this one. There's on the second carbon a bromine on a 3-carbon chain. Oic acid, butanoic acid, when they write out an organic acid, you'll always see the COOH. So that's going to be a really common thing you'll see in a condensed structural formula. So here's butanoic acid because there were 4. Here's butanone over here because we had 4 carbons. It's not an aldehyde because the double bonded oxygen was on this carbon. And you may have had a little trouble with that one and this one coming up with the structure. But remember, you can't add on any extra hydrogens. So if you had maybe started drawing this one as an ether, you wouldn't have had enough bonds and eventually would have had to go back to having this be a double bonded oxygen. And we have to include the number since the example in table R has one, so it's 2-butanone. Last one on the left here, we have a 3-carbon branch with an oxygen connecting it to a 1-carbon branch. And we name it with the shorter chain and then the longer one and then tack on ether. And then our last one, again, you might have tried to put this on as an ether, but then noticing that H, that might have helped you realize that was an alcohol group. You wouldn't have known where to put that H otherwise. So this is an alcohol. It happens to be a 3-carbon alcohol with the second carbon having the OH group. In fact, this is, you would know this as isopropyl alcohol. That's what that is. If it's on the center carbon, we say iso sometimes. So that's 2-propanol.